Okay, so I said, welcome to Unit 5. Isn't it a killer? Yeah, it's tough. Not gonna lie or sugarcoat it or anything like that. Proving your trig equations or simplifying your trig equations is extremely difficult at the beginning. Now notice I said at the beginning, that's where you guys are at. Once we keep working with this, and we will, because 5.02 I actually think is a little bit better than 5.01, but it falls along the exact same lines, and that we are going step by step with the simplifying process. The only difference between 5.02 and 5.01 is that in 5.02, they tell you what to kind of simplify to. So with the proving piece, you know exactly where your end goal is. In 5.01, they didn't give you that luxury. They just said simplify. And then you had to kind of piece together everything on your own. Excuse me, sorry about that. I just realized that I have the microphone on my headset and I'm coughing into that, so I apologize on the recording here, the outside recording I'm doing, because that's going to be extremely loud. I did have a question that somebody wanted me to review in class here at the start, and we'll go ahead and do that. It was question 6. So give me one moment to bring up question 6. We'll take a look at that one here and how we can maybe simplify that. We'll move into today's lesson, and then today's lesson, like I said, is going to mimic 5.01 very closely. So you will get more practice with these trig equations. And it will take a while to really kind of grasp and understand them. The good news is that I believe this is the last unit before the final exam. So we are spending a good solid month on this unit. Okay, we'll see how long question 6 takes. If it takes too long, we might have to circle back at the end of class for any additional ones. We'll see how long this one takes, though. Okay, so we need to simplify this. The first thing that comes to my mind is fractions. So, and I'm sure that's the first thing that you guys probably realized too, or were looking at there as well. So what comes to your mind with simplifying when you have fractions, adding or subtracting of fractions? A common denominator. Yep. So, and Isaias actually is going to give us the exact step to find that common denominator. Multiply by each other's denominators. So I like how you say bases there. Denominators is that term we're looking for. So in the first one, we've got to multiply by 1 plus sine of x. And in the second one, it's 1 minus sine of x. Now we are adding fractions, so we're a little bit fortunate here that we do not have to distribute a negative sign through that second fraction. So just keep in mind that you may have to do that. In this case, we are adding, so it's not needed. So I'm just going to combine those numerators. And I am, for right now, we will keep the denominators factored here, although I think what we'll probably want to do is expand those denominators, because in my head I can see that simplifying into a different trig function there. So using one of our Pythagorean identities, I can kind of visually see that we can maybe replace that with something in the future. All right, let's take a look at the numerator though. Can we simplify the numerator any further? So combine like terms, anything of those sorts. Yes, okay, what is that going to simplify to? The signs cancel out and it goes to a 2, Isaiah says, and Rebecca. Good, so I'm going to combine Isaiah and Rebecca's thoughts, add the ones together, signs cancel out, you're left with the 2 in the numerator. All right, knowing that it goes down to just a 2 there, we're going to have to go ahead and then distribute that denominator. Now, I notice that that's going to be your difference of squares, right? Because you had the exact same thing in your parentheses. The only difference is one's a minus and one's a plus. So as I go to expand this and distribute this, I know that the middle terms will cancel each other out. So technically, I'll just be left with the 1 times 1 and a negative sine x times a sine x, which is a negative sine squared x. Okay, I'm going to stop right there so that can maybe sink in a little bit. Any questions with how that simplified to the 1 minus sine squared x when we distribute things? Again, I skipped the middle part because that middle part of 1 times sine x and 1 times negative sine x, they will cancel each other out. That should go to 0. Okay, what can I replace the denominator with now? So that sine squared x and 1, having that combination, screams Pythagorean identity. Cosine squared. Yep. Now the only other thing is we can replace cosine squared x with a reciprocal function. So you can break that apart and you can think of that as 2 times 1 over cosine squared x. So you can kind of think of it like that. 1 over cosine, what is that reciprocal function? Secant squared. Yep, so I can bring this all the way back with no fractions involved down to a 2 times secant squared x. And that's what I would probably do for number 6 on that assignment. Rebecca, you said you had a question too. What was the one you wanted to peek at here? Okay, so 0, that's a good question, and I'm glad that you asked that. We didn't save that till the end. So a general question, how do you know what solutions are a part of 0 to 2 pi? And how do I know if you can include negative solutions? So 0 to 2 pi, as you're going, and sometimes they'll ask you to solve, and I don't have my unit circle with me right now, but you're looking for, like, you'll get down to something like cosine x equals 1. Basically, you have to use your unit circle and see where does cosine x equal 1. It should be in 2 spots. So that's the one thing that you're going to look out for is where does cosine x equal 1 on that unit circle. And you will get 2 locations. One of them will probably be a positive and one of them may be, I don't even want to say a negative because most of the times we give our answer in terms of radians. So when I think of that, cosine of x equaling 1 is at 0 and 2 pi, right? And that was probably a bad example. Maybe we should do 1/2. That's probably a little bit better example. So where does cosine x equal 1/2 on your unit circle? So let's grab that unit circle and we'll get a little bit more practice here with that. Pi over 3, and there should be another location as well. 5 pi over 3. All right, so what it wants you to do, if it tells you to find it on the interval from 0 to 2 pi, is yes, it is going to be 1/2 at those 2 locations, but the unit circle keeps going around forever and ever and ever. So technically we can hit that spot again, or those 2 spots again, if we add 2 pi. but it doesn't want us to do that. It only wants us to look at the unit circle one time around. So when it tells you that interval of 0 to 2 pi, it doesn't want multiple times around. It only wants you to look at it in one revolution around the unit circle. Because your answers should be listed in radians, so in terms of pi, I don't believe that you'll ever really get a negative answer for that because you don't have any negative radians. Everything is listed as like 11 pi over 3 or 7 pi over 3 or whatever that may be. So you shouldn't actually get any negative results when you're working between 0 and 2 pi. The only time that you may see a negative is if you're asked to solve something like cosine of x equals a negative 1/2. That's going to change the radians that you're looking for then, because now you're looking at the unit circle for where does cosine equal a negative 1/2. So that's really the only time that you're going to see a negative value is when the trig function itself equals something that's negative. But your answer, the output of that, will not be a negative answer. Yeah, the only difference between those two things is if 2 pi is included or not. So with the open parentheses there, 2 pi will not be included in your answer. But if it's that bracket, it means it will. So the parentheses means if your answer does equal 2 pi, you should not include it in your response. But the bracket means if the answer does equal the 2 pi at that location, you can include it. So one of them just kind of allows you to do double dipping almost. That bracket one allows you to say, well, 0 and 2 pi are at the same location technically, right? So you would essentially be listing that same value twice. The first one only lets you to list it one time. You're not really allowed to list it the second time around because it is technically the same location on the unit circle. Good. Any other questions with that? Hopefully that cleared it up a little bit. Okay, great. So keep the questions coming. Like I said, this is an extremely difficult unit at the beginning for sure. It's going to take a lot of patience and a lot of persistence and resilience and all that good stuff that makes us really kind of hate math at times. But the good news is that you'll get through it. You'll work through it and you'll be a brighter math student because of it, right? So I do remember being frustrated myself many years ago when I first was introduced to this, but now look at me. I can do them with no hesitation, although it is quite some time later, but I digress to that fact. Okay, so let's get some more practice with these trig functions and these trig identities. All right, so like I had said, 5.02 I actually think hopefully will go a little bit smoother than 5.01 because you have an end goal that you're trying to reach. So when you're trying to prove an identity, you need to show the steps along the way on how you're going to simplify to equal the right-hand side or to equal the other side of your equation here. So it says prove this algebraic identity and show that this mess on the left actually is going to simplify down to just a 2 that you have on the right hand side. All right, so this is not a trig identity. This is actually just an algebraic identity. So I'm just gonna show you, remind you kind of the formatting that we're looking for. First of all, without using any trig. And then once we see kind of the formatting that we're looking for, we'll start introducing those trig functions and following suit with those. All right, so if you wanted to show that this is going to simplify down to a positive 2, what would you end up doing for this? Combining the fractions, yeah. So finding the like term or finding that common denominator and then subtracting the fractions. Yep, so common denominator, I'm going to put parentheses around here because it is a very common mistake for students to say, well, they got an X and they got a 1, so maybe the only thing that's missing is a plus sign or a minus sign or a 1 or something like that. We don't want to make that mistake, right? So the first one we have to multiply by what? To find that common denominator, what do I need to multiply fraction 1 by? Yep, the x plus 1. And I always like to play that game. What is it missing, right? So what is that first denominator missing that the second one has? And it's missing the factor of x plus 1. What is that second fraction missing that the first one has? The x minus 1. All right, and now comes the fun part of our algebra here is we've got to distribute to kind of combine those like terms, distribute the negative sign so that we can subtract those numerators and simplify if we can. Hopefully this will go smoothly, we'll see. And I think I may actually take a little bit different approach than multiplying through by everything. Okay, hear me out. This is a little bit crazy. Can we factor the x squared minus 1 that I have in the numerators up here? Can we factor that to break it down? We can. Okay, let's do that. That's a difference of squares. So that's going to factor to an x plus 1 and an x minus 1. And then here's that extra x plus 1 that we multiplied by. And maybe we should have actually done this before our simplifying, but oh well, we'll see what it leaves us with. We may have done a little bit more work than we had to, but we'll come back to that. I am going to factor it again in the second fraction. And again, I think we may have done a little bit extra work, but that's okay. Because now what can we cancel out? Or can we cancel anything out from these fractions? Almost everything, yeah. So x plus 1 there, x minus 1 there, x plus 1 there, x minus 1 there. So what I'm really left with is an x plus 1 in my first fraction, and I'm going to distribute the negative sign now. So I'll have a negative x and a plus 1, it looks like, in that second fraction or from that second numerator. So now when I go to combine like terms, I have x minus x, that's gone. That goes to 0, and 1 plus 1 is a 2. Okay, and that simplification process there is now done, right? Because we showed that simplifying that now equals 2. So we are at the end of our proof. So we would finish. Yep. So those QED, remember, is that short acronym there for we're done. I can't remember the Latin phrase that it stands for, but that's what we use to show that we have reached the end of our proof. Okay, so that's kind of the steps that we're looking for, although with our trig identities, we know it's going to get a little bit more complicated than that, right? So let's start actually looking at those trig functions. Before I get there, there's just a couple general strategies I want to go over with you on how we're going to tackle these problems. So the first set of general strategies is you start with one side of your equation. Don't start with both of them, start with one side. And then you want to try to simplify that so that it equals the other side of your equation. And obviously, you're going to show that simplification process. That's the whole part of the problem, is showing the simplification piece. I always suggest kind of beginning with the more complicated side. Because if you can begin with that more complicated side, hopefully you can break it down and you can simplify it to get equal to that other side. It says if no other move suggests itself, convert the entire expression to sine and cosine. So in other words, if you get stuck along the way, see if you can try converting things to sine and cosine and having things cancel out or progress that way. Okay. Another one is combining fractions. So looking for those common denominators is going to be another step that they're going to use quite often. And then some other strategies that aren't listed on this slide, but I would recommend is if you run across like a really complicated proof, which there might be a couple of them that appear in the homework, but it's okay to start with one side and get as simplified as you can, and then realize you haven't reached that end point yet. But if you can't go any further with the one side you started with, switch to the other. See if you can now try simplifying from the other side and then finding the middle point at which they might simplify to. Because if you can find the middle ground by working on each side separately, then you can link the two together. So hopefully that makes sense. If there's time today, I have one in the works that will kind of work out that way. So we start with one side, we kind of hit a roadblock, so then we switch to the other, and then as we switch to the other, we meet that middle ground, and then we can link the two together to get the complete proof. Okay, any questions with kind of the strategies and suggestions with how we're going to go about simplifying and solving these trigonomic equations? Let's just wing it. I like it. All right, we'll learn as we go. All right, so the first one we're going to look at is prove that tangent x plus cotangent x equals secant x times cosecant x. All right, so, right, let's hope not. But for this one, some of them you might not be able to pick out a more complicated side. I would think if there's any adding or subtracting, that might be more complicated than the multiplying and dividing. So my suggestion is to start out with the side that has adding or subtracting with it. So in this case, it's the left-hand side. All right, what suggestions do you have for me on how I can simplify the left-hand side of that problem? What would you try to do if you saw this? So after staring at 5.01 for endless hours there, yeah, the first thing you would try to do is try to convert that to sine and cosine. Yep, exactly. So tangent is sine x over cosine x. And cotangent is the exact opposite, right? So cosine x over sine x. All right. There's step one. Then what would you do? Common denominator, yep. So what should I multiply the first fraction by to get that common denominator? Sine x. Okay. And what am I going to multiply second fraction by? Cosine x. All right, I can see some wonderful things happening with that, because that would leave us with the sine squared x plus cosine squared x in the numerator. And as I'm writing that out, hopefully you're thinking trig identity, because you see sine squared, cosine squared. Yeah, and you're thinking, okay, I can already replace that then with a 1 in the numerator. All right, we're not quite there yet though, because we're sitting at 1 over cosine x times sine x. How am I going to get from here to here? Secant x times cosecant x. What has to happen at this point? Yeah, you're going to kind of break it apart. So essentially, yep, this is going to be 1 over cosine x times 1 over sine x. So you can break apart that denominator using the multiplication to combine them still in the middle. So then Tommy said 1 over cosine x is your secant, and 1 over sine x is your cosecant. And now we have reached the end, right? Because we've reached the right-hand side of the equation, we know we can stop. Yay! We survived our first one. Any questions with that process? All right, let's try another one because we know practice makes perfect. It says match the function. All right, so we're starting with that function at the top there, and we have to decide which one of those choices it's going to simplify to. So this kind of mimics more what we did in 5.01 because we don't have a definite end result, but at least it gives us two options that we know that we're trying to work towards, one of those two. All right, so let's go ahead and start with that function that they list there. What ideas do you have to try to simplify that function? 1 over secant x minus 1 plus 1 over secant x plus 1. Yeah, I think we've seen enough of the fraction piece by now that we know we have to search for that common denominator. So I'm going to throw parentheses around that. Let's multiply the first fraction by your secant x plus 1 and the second fraction by your secant x minus 1. In fact, I'm going to make this, combine these two here. Let's see, we'll just move this whole thing over. And that means in the denominator, we'll have a secant x plus 1 and a secant x minus 1. Okay, then what? So now we worked, we got the common denominator. Where do we go from here? Combine like terms in the numerator. All right, so that's going to be a 2 secant x, right? Does that look right? Because the 1's are going to cancel each other out. Anything else we could do in that step besides just looking at the numerators? Yeah, let's combine the denominator. So we can FOIL that, and then we'll probably look for Pythagorean identity. Yep, so to distribute this, secant x times secant x is secant squared x. Notice that the middle terms will drop out because they're opposites. Secant x times negative 1 and secant x times positive 1. So the middle terms are gone. And then you just have a minus 1 at the end. Now, Isaias already said that after we distribute that and combine those like terms, that we probably should search for a Pythagorean identity, and I agree. Is there one that we can replace the denominator with? A tangent squared x. Beautiful. Okay, that did make our lives a little bit easier, although it doesn't look like it. what might you do from this point? Change into sine and cosine. Yep, so once you get to that kind of the point where you're stuck, you don't really know what else to do, change to sine and cosine. I'm going to kind of do multiple steps here. Maybe I won't. I'm going to write it a little bit different, I guess, because I don't want to lose you guys along the way. Notice instead of the fraction, I'm going to put a division sign here. And this is going to seem a little bit crazy, but secant is 1 over cosine. So essentially that's going to be a 2 over cosine x divided by tangent is sine squared over cosine squared. Okay, and the reason that I wrote it now linear like this instead of vertically, or horizontally instead of vertically, is because I notice I can't divide fractions, but I can change this to a multiplication problem. If I change this to a multiplication problem, I have to take the reciprocal of that second fraction. So I was kind of hoping that if I wrote it like that, you would notice that we do need to change this to a multiplication. Changing it to multiplication allows us to simplify. What is that going to simplify then? Or how can I simplify that further? The cosine x is going to cancel. Take out a cosine x. That's essentially just going to drop the exponent by 1 in that numerator then. All right. We are super close to getting our answer. In fact, you can probably jump to the conclusion. Now you know which one it's going to match up to. Which one is it going to match up to out of their two choices? It's going to match up to number 1, right? So now we just got to kind of finalize those last couple steps to get it there. Well, we got the 2. But now I'm going to split up what I have left. So I got a cosine x and then a sine squared x in the denominator. I'm going to break that up as sine x times 1 over sine x. So we can do, and this is where it gets a little bit chaotic, is knowing when to break it up like this. But having that end result hopefully will help that process a little bit, because usually we don't break it up until the very end to write it like one of the choices. That is then going to simplify to your cotangent x times cosecant x. And I ran out of space there, but I'll see if I can squeeze that in. All right. Any questions with that one? So again, that one, I would say it was a little bit more challenging. It was definitely a lengthy one compared to some of the other ones. But any questions with that? All right. Let's take a look at this one. Prove the identity that cosine of t divided by 1 minus sine of t equals 1 plus sine t over cosine t. All right, now this one is a little bit tricky because we don't really have a more complicated side. They're both the same. And we would kind of hit a roadblock almost right away because we're not quite sure what to do. So if you run into a problem like this where it almost looks identical on both sides of the equation, start where you have more in the denominator, because anytime you have more things in the denominator, hopefully there's a process that allows you to kind of maybe rationalize the denominator or try to simplify that somehow. So I would start with the left-hand side of this problem. And this is where you might run into a roadblock right away because you're like, I don't see anything that allows me to simplify or change things from here because I don't have any squareds, so I can't use the Pythagorean identity. I don't really see any reciprocal functions I can try to replace things with. Where do I go? Well, because we started with the more complicated piece in the denominator, let's try to rationalize that. How would you try to rationalize the denominator? So when we hear that term rationalize, what comes to mind? Multiply by its conjugate. So I would say not a 1 minus sine t, but by its conjugate. So let's, because essentially we don't want to create more of a mess in the denominator, but if we multiply by the conjugate of it, we're at least hopeful that some of the middle terms will drop off when we have to start distributing. So if I multiply by the conjugate, which is 1 plus sine of t, let's distribute and see what we get. Now we're allowed to do this because we're just technically multiplying by the fraction of 1 as long as we do it to the numerator as well. So we can do this because essentially we're just multiplying our problem by 1 and not necessarily changing the value of it at all. All right, let's see what happens when I distribute this now. Let's see, no, I'm going to keep the numerator separated right now. But the denominator is what I'm more interested in because I'm hoping that by distributing in the denominator there, it's going to allow me to maybe simplify with the numerator. What is that denominator going to distribute to or expand to? They're opposites of each other, so we know that the middle terms should drop out. Yeah, so 1 times 1 is 1. The middle terms will drop off, so then you're left with a negative sine t times a positive sine t. So that's a negative sine squared t. All right, you have a sine squared and a 1. That should scream Pythagorean identity. Fingers crossed. Does it scream Pythagorean identity? Can we replace it with something? A cosine squared. Awesome. Yeah, you can use x, that's all right. I know they like to switch the variables up on us. It doesn't really change anything, the variable we use. So if you were to put x there instead of t, that's okay. I wouldn't hold it against you, but technically we should keep it the same throughout the whole problem. Good. Knowing that simplifies to cosine squared t, now what can we do? We see a little bit of movement now. Yep, the cosine t is going to cancel out with the little squared part below. And because I left that factored, we've now reached our end goal. We're done. Woohoo! Because notice we have the right hand side of the equation now. 1 plus sine t over cosine t. So if you ever are presented with a problem that resembles something like this, always start with something that's maybe you can multiply the denominator by to try and use a Pythagorean identity of some sort to try to kind of cancel things out then. Okay, questions with that? The next one is the fun one. All right, so the next one is that example where I told you you may hit a roadblock when you start with one side and then eventually you'd have to start with the other to simplify and see if you can meet in the middle ground somewhere. All right, this is that example. So I'm glad that we got to it. I'm not sure if we'll get much further after this because it is going to be a lengthy process. So heads up with that. When I look at this problem, the more complicated side would be which one? So which side would you generally probably start with in this example and try to simplify? The left, yeah, both look pretty gross, but the left one has a fraction in it, and that one should always scream, start with me. So I would agree, let's start with the left-hand side. I'm going to work in different colors because I'm going to need both sides of the board here, but we'll start over here. All right, if we're going to start over here, and I'm going to use X just because I'm more familiar with writing X than you, so bear with me there. What are some ideas on how I can try to simplify that? I do see a cotangent squared. So anytime I see a squared, I think Pythagorean identity. Yeah, let's replace cotangent squared with the Pythagorean identity of cosecant, squared minus 1. All right, here's the crazy piece. Because I can see that I have a cosecant and a 1, maybe we can try to get that to simplify somehow, right? So the only way I can see that maybe we can get it to simplify is if we try to factor the numerator. Any ideas how we can maybe factor the cosecant squared x minus 1? Difference of squares, very good. Cosecant x minus 1 times cosecant x plus 1 all over 1 plus cosecant x. Can we cancel anything from the numerator and the denominator? Yes, because addition is commutative, so these two pieces with the plus signs can cancel out. And it brought us all the way down to a cosecant x minus 1. And now we hit a dead end, right? We can't really simplify much further other than changing that into a 1 over sine x minus 1. But that still doesn't get me anywhere near the right-hand side of the problem, right? So we're pretty far away from the end goal, which is the right-hand side of the problem. So we kind of hit a roadblock. So we stop and we're going to leave the work there and we're going to switch sides to the problem. I said, okay, well, that didn't get me too far. Let's see if I can start with the right-hand side of the problem and try to simplify that. Maybe we'll hit that cosecant x minus 1 in the middle there, and we can find some middle ground of what to do in the proof. All right, so coming to the right-hand side, we have cotangent x times secant x minus tangent x. What would you do to try to simplify this? Yeah, change things to sine and cosine. Yep, so change things to sine and cosine. So everything, we're going to try to rewrite that. Yep, change all of that to sine and cosine. All right, so cotangent x is cosine over sine, right? Secant is 1 over cosine. And tangent is sine over cosine. Okay. Now that we changed it all to sine and cosine, what do we do from here? Oh, you could subtract the fractions. You could. Yep, that's not what came to my mind right away, but we can. Let's see, that gives us a 1 minus sine x up here. Okay, so there we go. Those are combined. Then what? Multiply. Cosine x will cancel out. We're getting there. Then what? Yeah, you can break it apart. So if we break that apart, that's 1 over sine x minus sine x over sine x. So if I break that apart, and I can because it has the same denominator there, that is going to be my cosecant x minus 1. And we just met in the middle ground now. So what we would do to actually write this formal proof is we would start over here on the left-hand side in blue. We would write all the steps that we had for this simplifying. Once we got to cosecant x minus 1, now we know what to do in reverse order to get back to this starting point over here. Right? So this is what I was talking about on meeting in the middle ground. So the formal proof, when you write it all out then, is going to be really long because you're going to come this way, this way, this way, this way, circle back, and follow these steps to get to your end result. What would I have done first, like in this problem? You guys did exactly what I would have done. The only difference that I had in my work versus what you guys did is back here with the inside parentheses, I distributed first instead of combining these. Distributing back here, it allows me to not have to break it apart at the end over here. So essentially it's one step less if I would have distributed up here instead of combining inside parentheses first. That's the only difference that I did. But that doesn't mean that your way or what we did here on the board is wrong either. This is still correct. Essentially, just distributing first would have saved us one tiny step in the long run. It's slightly faster, just slightly, but not much. It would have saved you this step right here, these two steps essentially. I don't think you would have needed necessarily these two steps. Or this one of the steps in there. All right, that was a really lengthy one. Questions with that? The good news is they're not all going to be that difficult. So that is the good news. I promise it won't be too much more challenging. Although Unit 5 is going to be a tricky unit. I do want to just stress that now, is that it probably will test your patience a bit. So hang in there. I didn't get to everything here, but just some heads up and some tips that I would probably do for some of your homework questions here. In this one, I would probably expand the 1 minus tangent x squared. Don't just square both pieces. That actually means to multiply it out, right? 1 minus tangent x squared is the same as 1 minus tangent x times 1 minus tangent x. So for this one, I would actually start with that left-hand side and distribute everything to see if I can simplify that down to the right-hand side. For the last one, obviously that left-hand side looks a little more daunting than the right-hand side. I would look for a Pythagorean identity, because I see the squared and 1, so that screams Pythagorean identity. And then I'd see if I can break up the fraction since it's over cosine. See if you can simplify it from there. All right, that was the last one that obviously we didn't get here today. Any major questions with 5.01 or 5.02? Again, they kind of go hand in hand together. Okay, again, don't get frustrated. Take a break if you need to. If you feel yourself getting really overwhelmed, I don't want you guys spending hours at a time looking at one problem. That's not the goal of these. So if you do find yourself really struggling, take a break, come back to it, because sometimes a break is what's needed. And then you can come back to it with kind of fresh eyes and start over again, and you may just have that breakthrough that you need. All right, so don't give up with these. We'll keep looking at them. Today's Tuesday, right? So Thursday, we'll start off class by going over any major issues that you had with either 5.01 or 5.02 that lesson. So we'll actually look at a couple practice examples if we need to, or homework questions if we need to. All right, that's all I got for you today, though, so I'll let you guys go. Have a great rest of your day, and I'll see you again Thursday morning. Bye, everyone.